Hello everybody, this is Dr. Nur Badsha from University of Engineering and Technology, Peshawar. Today's lecture is about solution of ordinary differential equations by using Laplace transform. It's the continuation of last lecture, which was labeled as part 1. In this part, what do? We'll be solving those ordinary differential equations which involve a unit step function as an input function or the inflow, or it will be involving a Dirac delta function. Right, unit step functions are used in a case when the input or the inflow or the source term of the differential equation that is a piecewise defined functions, whereas Dirac delta functions are used in physical phenomena which involve impulsive forces or impulsive phenomena. Okay, so let me recap what we have done in last lecture. You know that differential equations, they contain derivatives, and so we need to know how do we convert those derivatives into uh, uh, algebraic expressions, right? So the process of solving differential equation by using Laplace transform is we first apply Laplace transform on both sides, right? And that will convert the given differential equation into algebraic equation, right? So you'll be having an algebraic equation in which the variable will be Laplace of y of t. You may represent that by capital Y of s, right? Y of t. And then we do what? We solve this equation for Laplace of y of t, right? And then at the end we apply Laplace inverse to find y of t. So in this case, y of t is equal to Laplace inverse of g of s. So just to get all these information, what do is, I said earlier, the differential equation which is based on y of t, right, which will be involving derivatives of y. It could be first order, it could be second order, it could be third order, and we want to convert that to an algebraic equation as explained in the last flow chart, right? So we need to know how do we find Laplace transform of derivatives, or what are the algebraic expression for Laplace transform of derivatives. So you know, first order derivative Laplace, that is equal to s times Laplace of y of t minus y of 0, and Laplace of y double dash t is, that is s square Laplace of y of t minus sy 0 minus y dash 0, and so on, right? And we have derived a method, a formula for finding the solution of a differential equation by Laplace transform directly, in which we consider a general equation. It was a y dash y double dash plus by dash plus c is equal to f of cy is equal to f of t, and then we solve that equation for y of t after applying Laplace transform. See, this was basically used, the Laplace transform was used for this. A y double dash plus by dash plus cy is equal to 0 if this is the equation. So we applied Laplace transform on both sides. So we got Laplace of y double dash plus b times Laplace of y dash plus c times Laplace of y is Laplace of f of t, which was f of s. And then using the expression for Laplace of y double dash, which was s square Laplace of y minus sy of 0 plus minus y dash 0, and then we applied an expression for Laplace of y dash, which is s Laplace of y minus y of 0, and we just replace this one there. So we had an equation like the involving Laplace of y dash. We said this is our y naught, whereas y dash of 0, this was given as y1, right? So using all these notations or observations, we'll be having as plus y plus by naught. As is coming from where? From the first, because a is multiplied with this expression, so we'll be having what? As, you see, plus the next one is bs, because b is multiplied with y dash, so it will be bs Laplace of y. And similarly y1, this is by naught, sorry, because y0 is y naught. So we have combined the coefficients of y naught here, ठीक है, और इस तरीके से हमारे पास जो y dash है वो y1 के बराबर है, and that is containing a1 because of this one, right? So after solving this for Laplace of y, and then solving for y of t, we apply Laplace inverse. So we may use this formula directly for solution of a differential equation by using Laplace transform. इसमें हमें वाई पी और वाई सी को सेपरेटली सॉल्व करने की ज़रूरत नहीं होती. वी डू दैट कलेक्टिवली, राइट. एंड सिमिलरली हमें वाई सी में जो आर्बिट्री कांस्टेंट्स हैं C1 C2, उसके लिए अलग से सिस्टम को सॉल्व करने की ज़रूरत नहीं है. वी डू एवरीथिंग इन द प्रोसेस. So this will be a solution which will contain the particular integral, which will contain the general solution, and which will obviously then find C1 C2 simultaneously. Okay, right. So I may use this formula directly. ये हमने already discuss किया था last lecture में, last video में. Okay, तो अभी हम जो बात करने जा रहे हैं, हम उन इक्वेशन को सॉल्व करेंगे जिनके राइट हैंड साइड में क्या होता है, जिससे अब बेसिकली एफ ऑफ एस पे इफेक्ट होगा. ये वाला पार्ट इट रिमेन द सेम. तो एफ ऑफ एस जो होगा दैट विल बी फाउंड बाय यूजिंग Laplace of some function of t into a unit step function ut minus a, or it will be a delta function, so that is delta t minus a with Laplace transform was already discussed, that is e power minus a s divided by s. So we're going to use all these expressions to solve differential equation with this type of right hand sides. So how do we do that? Let me solve this differential equation first. Okay, we have a first order differential equation, y dash plus y is equal to f of t with initial condition of 5. So you see in this case a is 0, b is 1, c is also 1, y naught is 1 5, whereas y1 is obviously 0. F of t in this case is what that is a piecewise defined function, which will be given as a 0 for t in the interval 0 to pi by pi, whereas its value is 3 cos t with t is greater than or equal to pi. So we first express this as f of t as a unit step function. So the first part is 0, and we have ut minus 0 minus ut minus pi. I'll explain that in previous lectures. So we simply multiply the value of a function into ut minus the first the left end of the interval and minus ut minus pi. But because this is 0, so everything will be 0. Plus 3 times cos t, that is the function, okay, and multiplied by what, that will be ut minus pi. So from here we will be finding f of s then. Okay, so f of s will be what? That will be Laplace transform of this thing, that is Laplace of 3 cos t ut minus pi. Okay, now you should remember from previous lectures that how do you find Laplace transform of this type of function? We use t shifting theorem, or we do call it second shifting theorem. So in this case we are given f of t minus pi, that is equal to cos t, which means f of t is what? F of t will be, keep in mind ये जो f of t है और यहाँ पे जो हम f of t का जिक्र कर रहे हैं वो डिफरेंट है. मैं जनरल सेटअप में इसको फाइंड करना चाह रहा हूँ लेप्लास को. तो f of t will be what? That will be cos t plus pi, where cos t plus pi that is equal to minus cos t, because it's applying cos alpha plus beta formula. So we have cos alpha cos beta minus sin alpha sin beta, keeping in mind sin pi is 0. So we get cos t into cos pi is minus 1, so it's minus cos t. So Laplace of this will be what? That will be f of s. In this case it will be minus s divided by s square plus 1. But according to second shifting theorem, it says that Laplace of f of t minus a ut minus a, that is f of s into e power minus as. Okay, so we can do that. So by using this concept, यहाँ पर a की जगह pi है, so we'll be having what? This is equal to we found that minus 3 cos t, sorry, its Laplace is minus 3 s into s square plus 1 e power minus pi s. This is the Laplace transform of this function. Okay. Now, putting the value in the formula, we have y is equal to Laplace inverse of, the formula was, I explained earlier, that was as plus b, as plus b into y naught plus ay1 divided by plus f of s, obviously, divided by this one, which is the characteristic equation. It will become s plus 1, right? So putting the values here, a in this case is 0 because we are having first order equation, so a will be 0, b is 1, y naught is 5, this is 0 as well. So altogether we'll be having 5 divided by s plus 1 plus f of s, which is minus 3s divided by s square plus 1 e power minus pi s, which might be written as Laplace inverse of, don't forget to write Laplace inverse here as well. That's the Laplace inverse of this. So we have Laplace inverse of 5 divided by s plus 1, just gone a bit lower. And the next one is what? That is minus 3, and then we have s divided by s plus 1 into s square plus 1 e power minus pi s, right? And then what do? We have to do factorize partial fraction for this one. Okay, you can use shortcut method to find partial fraction of this, or you can simply use the other method as well, the long method. Okay, and Laplace inverse is applied on both one. Okay, so this will give you basically a function of, when you apply this one, so you have to apply Laplace inverse. Laplace inverse of, again, f of s e power minus as. This is the rule used for finding Laplace inverse as well. So this will be something like f of t minus a ut minus a, where u is the piecewise defined function. So now all you need to do, what you just find the partial fraction of this function 3 divided by s plus 1 into s minus s square plus 1. Okay, whereas this is simple, it is 5 divided by s plus 1. Sorry, it's not s square. The Laplace inverse of this one is what? That is let's get rid of this. That is e power minus t, and the rest is straightforward. You have to go for Laplace transform. You try. If you have any query, then you can just get back to me. I'll maybe leave a message in the text box. Okay, so let's do this one now. Again, the same concept will be used here. First, a in this case is what? That is 1, whereas b is 0. Right? C is equal to 1. Y naught is 1, whereas y1 is 0. F of t, which is again a piecewise defined function, will be written in the form of what? In the form of unit step function. So that is 1 into ut minus 0 minus ut minus pi by 2 plus sine t into ut minus pi by 2, which might be written as ut minus ut minus pi by 2 plus sine t. Can we write this in the form of t minus pi by 2? So if we have cos t minus pi by 2, so cos t minus pi by 2, that is equal to cos t cos pi by 2 plus sine t sine pi by 2. So we could write this as cos t minus pi by 2 into ut minus pi by 2, just to use second shifting theorem directly. So from here I would find simply f of s. So f of s is what? That is Laplace transform of ut is 1 over s. This is e power minus pi by 2s, and this is s divided by s square plus 1 e power minus pi by 2s, right? So the left side is what? Now altogether y of t, by using formula, that is a s plus b into y naught plus ay1 plus f of s divided by the characteristic equation, which is s square plus 1 in this case. Now putting all these values, a is 1, b is 0, y naught is 1, y1 is 0. So we'll be simply get s plus, in fact, s into 1 plus f of s, which was found something like that, that is s by s square plus 1 plus 1 over s square plus 1 into 1 over s. Don't forget to write Laplace inverse of this. The next one is plus 1 over s square plus 1. It will be in the bracket s by s square plus 1 minus 1 e power minus pi by 2s. Okay, or you can just write that separately as well, because it will make a bit things more difficult. So we have what? Altogether we'll be having Laplace inverse of we can do that separately now. Laplace inverse of s square plus 1, Laplace inverse of 1 over s into s square plus 1. We may write that one as Laplace inverse of s divided by s square plus 1 whole square into e power Laplace inverse of e power minus pi by 2 divided by s square plus 1 whole square. So again, it's a bit lengthy Laplace inverse. This is okay. This is simply cos t. Laplace inverse. In this case, we can use integration rule. We can use partial fraction rule. So this will be what? This will be integral of sine t, right, from 0 to t. Whereas in this case, we can use the partial fraction idea for both cases, and we can use a cover-up method as well. We can use convolution as well in both cases, and then applying again second shifting theorem to find Laplace inverse of this function. It's a bit obviously lengthy. um, Procedure is a bit lengthy. Okay, you see, if you want to find Laplace inverse of s divided by s square plus 1 whole square into e power minus pi s, I just gave you some idea, pi by 2s. So we will first find partial fraction of this one and then applying Laplace inverse. So this could be written as s divided by s square plus 1 whole square. So we can use the integration method, right? Or you can do some things like a partial fraction as well. That will be s divided by s square plus 1 as plus s square plus 1 and plus bs by this one s square plus 1 whole square. But in case of derivative rule, what do? We simply apply the rule integration from where to where? Okay, Laplace inverse of s divided by s square plus 1 whole square, which is Laplace inverse of s divided by s square plus 1 into 1 divided by s square plus 1. This is cos t steric sin t, right? So you can simply write in this form as well the solution, and then we write from 0 to t. This will be what? This will be cos tau into sin t minus tau and eta. So once you find Laplace inverse from here, you just integrate this one. So applying, obviously converting product into some technology or methodology, like we know that cos t minus cos alpha into sin beta, that is equal to 1 by 2 times sin alpha plus beta, this integration techniques, minus sin alpha minus beta. We can use this one as well. Okay, so once you have done that, at the end you will be doing what? You will be simply applying a second shifting theorem, that this will be f of t minus a, which is pi by 2 ut minus pi by 2. Okay, so once we have found f of t from here, right, so then we replace f of f with these quantities, right? So you can do that. Right. Next is a question which is using Dirac delta function. Okay. So the concept is same. You can do it directly as well. If you don't want to use formula, the Laplace of y dash, Laplace of y, and 4 times Laplace of Dirac delta t minus 1. अगर आप चाहते हैं कि मैं डायरेक्ट इसको यूज़ करूं, उस फार्मूले को यूज़ आप नहीं करना चाहते तो, whereas y of 0 is equal to 2, that is given. So we know that Laplace transform of y dash, that is s Laplace of y minus y of 0 plus Laplace of y, that is equal to 4 times e power minus s, because Laplace transform of Dirac delta t minus a, that is e power minus as. Now y of 0 is what? That is 2. So we can write that as s plus 1 into Laplace of y minus 2 is equal to 4 e power minus s, which might be written as s plus 1. Keeping in mind, you can use the formula I derived already, and I used in quite few examples as well. So that could be written as 2 times 4 e power minus s. Dividing both sides by s plus 1. So to find Laplace of y, that is 2 divided by s plus 1 plus 4 divided by s plus 1 e power minus s. We need to find y, so y is Laplace inverse of 2 divided by s plus 1 plus Laplace inverse of 4 divided by s plus 1 e power minus s. The first part will give you simply e power minus t, whereas in this case we'll be using second shifting theorem. Laplace inverse is 4 by s plus 1 e power minus s. So we first find Laplace inverse of this part. So it's a is come on. Laplace inverse of 4 divided by s plus 1, that is equal to 4 times e power minus t, which means Laplace inverse of 4 by s plus 1 e power minus s, that will be f of t minus 1. So we'll take that is 4 times we'll take 4 times e power minus t minus 1 ut minus 1. That's the Laplace inverse of this part. So the solution is y is equal to 2 e power minus t plus 4 e power minus t minus 1 ut minus 1. That is the solution for differential equation in terms of unit step function. But if we want to write that in the form of a piecewise defined functions, we just impose restriction on 1 t less than 1. It means this part will be 0, so we'll be getting only 2 times e power minus t. But when t is greater than 1, in that case we'll be having what? 2 e power minus t plus e power 4 e power 1 minus t, because ut minus 1 will become what? That will become 1 when t is greater than 1. So that's the solution in case of piecewise defined function, but you can have solution in unit step function as well. It's the same type of question, but we are having now a second order differential equation. Okay, so in case of second order differential equation, what do? You can again use the formula directly, right? Let me do that in this case. A is equal to what? A is equal to 1, B is 0, C is 1, whereas f of t in this case is 4 delta t minus 2 pi, which means f of s is, that is 4 times e power minus 2 pi s, whereas y naught is 1, where y1 is 0. Now y of t, which was defined as, ये आपकी मर्जी है, आप चाहे फार्मूला यूज़ करते हैं या चाहे आप उसको प्रॉपर तरीके से करना चाहते हैं. It can be done in either way. Okay, so in this case it is Laplace inverse of, keeping in mind as, so a is 1, so I'll just write s, plus b, which is 0, so gone, and with y naught is also 1, so I'll just write 1 with it, plus f of s, which is 4 times e power minus 2 pi s. Keeping in mind plus y naught as well, but by naught, but b is 0, so that is gone as well. Divided by the characteristic equation for it in terms of s, so it is s square plus 1. Right, so you can just use this formula directly as well, अगर आप वो steps बीच में नहीं करना चाहते हैं तो. So that will be Laplace inverse of s divided by s square plus 1 plus 4 times Laplace inverse of 1 over s square plus 1 e power minus 2 pi s. The first part is simply cos t, whereas the second part is what? We would first find Laplace inverse of this one, which is sin t, लेकिन हमारे पास क्या होगा, ये साइन टी माइनस 2 पाई हम लेंगे, यू टी माइनस 2 पाई, यूजिंग सेकेंड शिफ्टिंग थ्योरम, कीपिंग इन माइंड, बिकॉज इसका लेप्लास इनवर्स क्या होता है, इसका लेप्लास इनवर्स साइन टी है, और यहाँ पे हमारे पास जो है ए की वैल्यू जो आते हैं वो 2 पाई है। तो जब हम इसको कन्वर्ट करते हैं एफ ऑफ टी माइनस ए यू टी माइनस ए बाय यूजिंग सेकेंड शिफ्टिंग थ्योरम, सो विल बी गेटिंग साइन टी माइनस पाई, लेकिन ध्यान में रखें कि साइन 2t माइनस पाई दैट इज सेम एज साइन टी, बिकॉज साइन टी का पीरियड जो है वो क्या होता है, वो 2 पाई है। So we can have, this is again sin t as it is into ut minus 2 pi. And now if you want to write that as a piecewise defined function, so it will be cos t when t is less than 2 pi. Maybe you can write greater than 0, but are equal to 0. We don't do that. We know t is greater than 0. And this will really be, its value will be cos t plus 4 sin t when t is greater than 2 pi. Because when t is greater than 2 pi, ut minus 2 pi will be 1. This is also there, so we have cos t plus 4 sin t. That's the solution of this differential equation. Right, another question is, again we can use the same formula, but we are having now y double dash 4y dash plus 5y is this one, okay? Right, so the formula will be what? A is equal to what? That is 1, b is 4, whereas c is 5. F of t, which is delta t minus 2 pi, which means f of s will be e power minus 2 pi s, whereas y naught, y1 both are 0. Now using formula y of t, that is equal to Laplace inverse of as plus b into y naught, so that's gone because y naught is 0. So the first part as plus b into 0 plus a into 0 plus f of s divided by the characteristic part. Sorry, I just can't draw a straight line. So that is s square plus 4s plus 5. So altogether we're having Laplace inverse of e power minus 2 pi s divided by s plus s square plus 4s plus 4 plus 1. This is Laplace inverse of e power minus 2 pi s divided by s plus 2 whole square plus 1. Now using first shifting theorem first and then applying second shifting theorem. Okay. So in first shifting theorem, what is Laplace inverse of this function? So you say is Laplace inverse of 1 divided by s plus 2 square plus 1. So using first shifting theorem, it will become e power minus 2t into sine t. F of t minus a, f of s minus a, Laplace inverse is what? That is e power, e power at into f of t. And then by using second shifting theorem, this will become what? You will write same thing as it is. It will be e power minus 2 t minus 2 pi sine t minus 2 pi into ut minus 2 pi, right, by using second shifting theorem. We can write e power minus 2 t minus 2 pi, again sine t minus 2 pi is sine t into ut minus 2 pi, which could be written in the form as piecewise defined function. So its value is 0 when t is less than 2 pi, and its value will be e power minus 2 t minus 2 pi into sine t when t is greater than or equal to 2 pi. That's the solution of this differential equation. Okay, so let's another example question or practice question. It has two different type of source points, right? The concept is same. We can write this solution as, you see, A is what? In this case, again, A is 1, B is 4, C is 13, right? Now, f of t, that are two functions, Dirac deltas, delta t minus pi plus delta t minus 3 pi. So that basically means f of s is what? That is e power minus pi s, e power minus 3 pi s. Whereas y0 and y1 both are again 0. Keeping in mind, whenever we have y0 is 0, y1 is 0, it means we'll be only having f of s. So y of t, by using formula, that is what? Laplace inverse of as plus b, that means basically s plus 4, but y naught is 0, so that is 0, plus b into y naught, so b is 4 into y naught is again 0, plus f of s divided by the complete characteristic equation, s square plus 4s plus 13. That means we could write it in the form, f of s is this one, so I just express this in the form s square plus 4s plus 4 plus 9, is what we have done in last case. F of s is e power minus pi s, e power minus 3 pi s. So this is basically same as 1 over s plus 2 squared plus 3 e power minus pi s plus e power minus 3 pi s. The first part will directly give you 1 over 3 e power minus 2t and then sine for the first part sine t minus pi ut minus pi plus 1 by 3 e power minus 2, this will be 2t minus pi, 1 by, this is minus 2, again t minus 3 pi into sine t minus 3 pi into ut minus 3 pi. Okay, so again you can write that in a piecewise defined way as well. One is t less than pi, the other one is t between pi and 3 pi, and the next one will be t greater than 3 pi. So when we take t less than pi, so everything will be 0. When t is between pi and 3 pi by 2, so we'll take only the first part. And when t is greater than 3 pi, we'll just take both the first one and the second one as well. So we'll be having one expression 0 here. The other expression is only the first part, as I said, 1 by 3 e power minus 2t minus pi into sine t minus pi is basically equal to cos t. In fact, minus sine t, sorry. So it will become minus sine t, right? Whereas the second part, you will just having this term plus the other term from the next one as well, right? So that's the solution of this differential equation. So thank you very much. I'll see you next time in another video. Thank you very much. If you have any question, any confusion, so please just drop a comment in the comment box. I'll get back to you. Thank you very much.